ඩිස්කෂන් එක මේ කොහොමද කරන්න අපි ඉංග්‍රීසි වලින් කරන්න ඕනද කියලා බලන්න කවුද ඉන්නවද කට්ටිය තමිල් අය මුස්ලිම් අය සෙට් එක නෑනේ අනුෂන් hello Anushan uh, so let's do the discussion in English then. So first in the paper we get 3 questions. First one we get 40 marks. What we have to do is just read a scenario and we have to draw the EER diagram. Then we have to map them into a relation. We have to make relations out of that. Then we have to do normalization part, and at last the SQL part we have. Uh, okay, so let's start. So it's 3 questions, not 4 questions like in other papers. And as they said, they will not change that as well. It will be same as before. Okay. So, so should I read this all? I think I should. And let's identify the entities before drawing an ER diagram. First, we should identify the entities, right? Entities and relations. Then only we can draw that. I guess you guys are ready to move. Let's go. How many records? And another thing, I don't know whether is there anyone that recording the session. So I don't know whether it will be able. Viman is there. You ask him. Okay, Viman is recording. Then fine. Let's start. How many records? Prestigious music record company is currently undergoing a redesign of its database to enhance operational efficiency. Drawing upon your experience as a database designer, your expertise is sought to design a robust database tailored to meet the specific needs of the company. Okay. That whole part is unnecessary. So I will share my whole screen. Otherwise, I will write the information I find when I'm reading the scenario. Now I will open my notepad and I think you can see this. Okay. I think the screen is clean, right? Ivan, is it alright? Okay. Then now we can start. Okay, we find our first entity, musician. And I will capture its attributes. First, it has an NIC, as they say. Each musician associated with Harmony Records possesses a national identification card, a name, an address, and a special. This is a special several phone numbers. Okay, then and also here NIC is serving as the unique identifier. Okay, right? So musicians can be categorized as either solo artist or member of a band or members of a band. Okay, so here what does it mean? So here what it mean is there is a there are two subclasses for this musician superclass. So I think you guys are familiar with this subclass superclass thing. Hold on, I had not. I put that into the group as well. Here, not downloads database. Scroll 3. Yes, superclass and subclass. I will like remind some theory parts as well. I don't know whether will this make the discussion more boring. I'm sorry about that. Superclass and subclass. Superclass. This is a general entity that holds common attributes for a set of related entities. It's the parent in a hierarchy. There are like this is an example. There are cars, trucks, vans, and etc. All together, they are vehicles which have model, year, fuel type, fuel type attributes in common. So in this case, vehicle is the superclass. So about subclass, this is a more specialized version of a superclass, inheriting attributes from the superclass while also adding its own unique attributes. So when it comes to a subclass, it inherits all the attributes of its parent, the superclass, and subclass also can have their unique attributes. So in our vehicle example, car, van, truck are subclasses. They have their own attributes like number of doors, cargo capacity, like that. So okay, okay. That's just a simple reminder. Let's move. So I will note down that subclass thing. So a musician can be a solo musician or a band member. And additionally, for solo artists, their age is recorded. So their age is recorded. For band members, band name is recorded. So these are subclasses, unique attributes. Okay, that is for musicians. So then next we have what do we have for the musical instruments utilized in harmony records recording. Each instrument is assigned. Okay, now we have another entity, instrument. There's a unique identification number. I will say it's instrument ID. Then a name, piano, violin, drum. Okay, a name and a music key. Okay, fine. Uh, music key. Musicians may play. Okay, now they are now saying about a relation. Musicians may play multiple instruments, okay, and a single instrument may be played by multiple musicians. So now they are telling about the relation about musician and the instrument. So as it say, Isn't this what they say? Musicians may play multiple instruments. Musicians can play multiple instruments, uh, and a single instrument can be played by multiple musicians. So, should I write this as a sentence, or maybe I will just write this like this? I will write it like this. Is this okay? Is this understandable if I write it like this? Otherwise, it is too long. Is it okay? I write it like this, just like this. The next one, okay. I think it will be fine. Okay, then let's move songs. Okay, songs performed by musicians are recorded within. Okay, now they are telling about another entity. Song. There are information such as song ID, title, author. Every song must be associated with a genre. Okay, and the genre can be linked to one or more songs. Okay, it's about the relation. Every song must be associated with a genre, and the genre can be linked to one or more songs. Song, song. I think it is pronounced as genre, as I have heard. I don't know. Genre or genre, whatever. As far as you understand this point. Uh, every song must be associated a with a genre, and the genre can be linked to one or more songs. Genres are defined by a genre ID. Okay, now we are getting the attributes of them. Genre ID and a specific style, while a variety of genres, including electronic music, pop music, and classic music exist. Each have unique attributes. Okay, now again, it is telling us about subclass, superclass thing. So what are they? For electric music, uh, electric music, it has tempo as its, and for subgenres of Okay. Okay then. Now each song is performed by one or more musicians, and musicians can participate in multiple songs. So musicians can it's another relation. So it's also each song is performed by one or more musicians, and musicians can participate in songs. Many, many songs for a single musician and multiple musicians for a single song. Okay, albums produced under the Harmony label have a unique identification. Okay, this is another entity album. Okay, album ID. Then it has a title. A title, copyright date, copyright date. Then what? Then what? Then what? It's it. Release. Each album comprises a set of songs. So one so album called member songs, and no song can be featured more than one album. Okay, okay. That means album. Have any please no like by that one yeah, too many things. Oh, okay, is another relation about albums. Each album, no. Each album is associated with a single musician. Okay, so for one album, there's only one musician, single musician, who serves as its producer. Musicians may produce multiple albums, but a single producer. Okay, cool. Then each musician in Harmony Records is required to sign contract. Okay. Contract. One contract belongs to only one musician. Okay, now we are getting the relation before everything. Hmm? Ramzan, I don't think. Where was I? Contract musician. I'm sorry that Roy is distracting me. One contract belongs to only one musician, one to one. So about for band members, the entire band collectively sign a single contract. Okay, the contract includes a contract number. Okay, mm, consequently, the duration of the contract is also recorded. Okay, that means this duration is a derived attribute that we should derive it at that from start date and end date. So I will write that duration. Actually, when we are mapping this into tables, we don't write this thing. So now I think I captured all the parts, but I should write this part. I should keep this in my mind that for band members, the entire band collectively signs a single contract. Okay. So about getting these details, is it okay? Is it fine? Okay. Okay, if it is fine, then good. Then we can move. Now we have to draw the ER diagram. Actually, I drew a half in this thing because it will take time otherwise. Mm, so I first got the musician part. Musician. So it has NIC, name, address, and several phone numbers. I should change this. Why should I change this? Several phone numbers being its multi-valued attribute. So in multi-valued attributes, I cannot do it like this. This is how you denote multi-valued attributes in ER diagrams or EER diagrams. So now it's correct. And phone numbers. Now I done this part. Then about subclasses. So this is how you denote subclasses, but it's okay to which direction you make this, but uh, normally it is to the downward, to the down, but uh, here I did not have space, so I just made it like this. Okay, then don't think about this D and this double lines for just now. So I just made these two subclasses, solo and band member, and I added this special unique attributes for them, age for this solo one and band name for this band one. So I will make this more specific. Okay, right. So now the D thing. This is there are, when it comes to this subclass superclass thing, there are is a constraint. There are two constraints. First one is disjointness constraint. So disjoint means like nothing. A car cannot be a van at the same time, right? So that is called a disjoint. So at the same time, so in this case, okay, I will use the example in my note. Disjoint: an employee cannot work for two or more titles like secretary, technician, engineer, only one title at a time. So this is how you denote it using D. So the other case, there are two types of this in this disjointness constraint. So what is the other thing? Overlap. So a person can be an employee and a student at the same time. So think about in our UCSC, there can be a student who's doing masters who can be a who can be an employee in UCSC. So that is an overlap. At the same time, the employee can be a student like that. This is the definition. An entity instance of the superclass can belongs to multiple subclasses. So in the disjoint, an entity instance of the superclass can belong to only one subclass. Okay. So now I think that part is clear. So for uh, so in this case, I chose disjoint because uh, musicians can be categorized as either solo artists or members of a band. So actually, I should write an assumption. I don't. So sometimes we can obviously take that it is disjointed if they strongly say that only be a part of one. So in this case, it is not that strictly saying that musicians can be categorized as either solo artist or member of of a band. Uh, Musicians can be categorized as either. Okay. So this is strictly saying as I feel. So it is, but it is good that tell that you assume that solo artist, a solo musician can only cannot be a part of a band member, and a band member cannot be a solo artist, like that as your assumption in case something goes wrong. So I assumed that it is disjoint, and I put a D there, not an O. Then here I use to this double line. Why did I use this double line? I will show the next constraint. Completeness constraint. The completeness constraint specifies whether every instance of the superclass must belong to at least one subclass. So try let's see an example. So in this as well there are two types: total and partial. So total mean every instance of the superclass must belong to at least one subclass. So it's like this. Now think there's a patient, and patient can only be two parts, no, outpatient or inpatient, or resident patient in this case. So there are no other types, no. If it a patient can only be outpatient or inpatient. So now let's think about this partial one. A vehicle, there are two subclasses as car and truck, but is that the only kind of vehicle? No, there are more type of vehicles. like bicycles. So like that. So there I cannot use two lines because I I haven't mentioned all the subclasses. It's there can be more. So in that case, it's partial. But in my question, can be either a solo member or a band member. So there cannot be other types, right? So I use this total thing. Is it okay? Have anyone got some question? Anything on this? ඔව් සාමාන්‍යයෙන් ඒ වගේ තැනක සම්ෂන් එක ලියන එක වඩා හොඳයි. දැන් මේකේ ගොඩක් එහෙම තැන් තියෙනවා. දැන් හිතන්නකෝ මේකේ මම ඒක ඉදි කියන්නම්කෝ ඒ අනික් ටික නම්. Okay, so are there any more questions? Union. Union, I'm confused with union. දෙන්නේ කියන්න බා. මමකට අදහස් කරේ. කැටගරි කියන කැටගරි සීන් එකට නෙමෙයි බං ඔක ඉන්නේ. ඔක කැටගරි කියන්නේ සුපර් ක්ලාස් කීපයක් එකතුලා හැදෙනවා වගේ එහෙම සීන් එකක තියෙන්නේ බා. මේක තමයි යූස් කරන්න ඕන එක as far as I know. හරි others. This is a 40 mark question. හරිද? අනික් අයත් අවුලක් නැහැනේ. ඉස්සරහට යන් කරගෙන. Okay, good. I was here. So now this part is done. Then instrument. Yes, instrument. Instrument one is not that complex. In instrument there's a instrument ID, name, and a music key. Now that's fine. Now the relation. There's a many to many relation as we identified. And why did I use this two lines? These two lines are full. I will show it. Hold on. I don't know whether it's in third one or second one. I think second one. Okay, this one, participation. Total participation and partial participation. So when every instance of an entity must participate in a relation, it is called total participation, shown as a double line connecting the entity to relationship. So now think. So this manages relation. This manages relation with department. So there should be somebody to manage the department now. So the department should participate in this manager's relation. But now next, let's go to this part, the other half of the manager's relation. So some employees are managers. They manage departments. But other employees, like let's say an engineer or a technician or somebody like that, so they don't need to be a part of that relation, no. So that is called a partial participation. I hope you got the point, right? So why did I so instrument must be played by someone, no. So it is obvious. But here this is an assumption. I assume that every musician plays an instrument. So it is okay that you say it as like some musicians may not play instrument. It is your choice, it is your assumption. Okay, so you can assume it. I can also use one line and say that I assume that some musicians do not play instrument. That is why I use this partial participation. Understand that part? Ah, so can an instrument play by itself? Somebody must play that, no? This place relation, somebody must, the instrument must be played, but musician doesn't need to play instrument. Maybe they are just singers, vocalists, like that. So is it clear what? Okay, and I added this mn in to show that it is many to many. It is fine that it is not a problem that you put in here. Yeah, just okay. Next one. What is the next one? Okay, now this until this we are done. Then song. Okay, song. Here the song. Song ID, title, author. They are all done. Then the genre or genre, whatever. Genre ID style. Genre ID style, and there's another thing. Now this has subclasses. I have not added them yet. It's a half diagram, so I will add these parts too. So I need to add a subclass, two subclasses, no, three subclasses, like this. I will draw. Okay, so in this case, I need to find their total of partial. Genres are defined by a genre ID and a specific style, while a variety of genres, including electronic music, classic music, exist, each having unique. So, in this case, I will assume that there are more genres. These are not the all. These are not all. There can be more. So I will just add a single line. Okay, and here I have to define this tempo, subgenre, and duration. Those things, fine. And also here I have to add this O or D. For that, I will have to read this once again. Every song must be associated and then when fine, yes. So here. Each having a unique attributes. It is important to note that the categorization is not exclusive. This categorization is not exclusive. Hmm. So what this mean, as I feel, it is important to note that that the categorization is not exclusive. Mean um, it is not exclusive. Mean inclusive. No. So I think this is overlapping. So one, so a song can be in pop at the same time in electric. I don't know whether are there genres like electric pop, classic pop. I don't know, but as it says, I think that's what it means. It is important to know that the categorization is not exclusive. I feel, I think it's what that one saying, right? And now I have to consider about this part. Song genre, many to one. So many songs can be a part of one genre, and now multiple songs can relate to one genre, and there's only one genre for a particular song. That's what it says. As I say, as I think. Now, you don't need these arrowheads, right? You just need to write the lines, but this diagramming tool just give me arrows, and it takes time to change that thing. Song has genre, and for a song there should be a genre, no? So I will add a double line. This participation is a must for a song, and genre also should have a song, no? So I say I will assume um, I as an assumption. Maybe I will not write this because it feels like obvious that every genre must have a song. Otherwise, why that genre is there? Like that, I feel. But in case you have a doubt, just write your assumption. It's fine. Normally, as I feel, Nosha madam is not that strict. If we write the assumption, I don't know as I feel. And here, what is this relation? Many to one. So multiple songs can relate to. It's okay, just to add in or whatever. It's fine.
Okay, now musician song relation. Okay, musicians perform songs and multiple musicians. A musician can perform multiple songs. A song can be performed by multiple musicians. Then the album thing. Album has album ID, title, copyright date. Okay, right. I added those parts, and then we have album song relation. Album song relation one to many. One album can have many songs, and a song can only have one album. This verb you add something appropriate. It is up to you to add the verb. Okay, here. And you cannot feature an album without a song, no? So this is what this is total, right? An album, there must be a song, no? Otherwise it cannot be an album. And songs are also featured in album, so song must be a part of an album too. And as this say, this here is side one. Okay, is this correct? Yes, I think. Then album musician. A musician can produce multiple albums. An album can be only produced by a single musician. This is what I did. And here, album must be produced by someone. No? That's why this total participation, right? And the about musician, so every musician doesn't need to produce an album, right? So it is partial. I guess it's fine. Then I did not add the contract part. I should add that part as well. Now where should I add that? I will make this a little down. Add this like this. Okay, contract now. Then science. Science. So here, as they say, each musician at Harmony Records is required to sign a contract. So it is obvious that this uh, musician must participate in this sign thing. Sign contract must be a part, and also why a contract without a musician? Ah, no, I forgot one thing. For band members, the entire band collectively signs a single contract. So in a band, maybe not all of them register. So they sign a collective uh, collective agreement or something like that. So I will make an assumption as they. This is an assumption. I will assume that there's only not all of them will sign. In band members, uh, they all signs a single contract. That's my assumption. But in contract, there must be someone to. Someone should sign the contract. No. So this is total, and it's 1-to-1. So now is it okay? We did all, I think. This is all. Any part which is not clear, please ask. It will not take you 1 hour like this. We took 1 hour because we explained to as well. No? And actually, this is the part you actually take some time. Other parts are just fine. Okay, these things. It's all right. What is okay? Let's move then. What we have to do now? Now we draw the EER diagram. Then ER diagram showing the necessary entities, attributes along with the primary key and relationships for the above in order to specify the cardinality and participation constraints. We did all of these things, no? For each relationship set, clearly state all your assumptions, if any. Okay, now map the EER diagram developed in A. About to a relational data model, underline the primary key for each relation. Okay, after you drew the ER diagram, now it will be easy for us. Okay, first we have musician. Now we are just making tables. When it comes to musician, now we cannot just make a table and like musician and NIC is the primary key address and name they are there and just three columns. No, we have to consider how to map these things in a table. So where is that note? I think it is not there in this note. It's in fifth one. Yes, mapping ERD to relational models. Cool. What was my problem? My problem was mapping superclass subclass relationship types. Okay, then I should consider about what? Participation and disjoint constraints. Okay, participation and disjoint constraints. So let's see what are my participation and disjoint constraints. Participation is total disjoint. Total disjoint. Total disjoint. Let's go total disjoint. Okay, here total participation disjoint constraint. So steps: do not create a separate table for the superclass. Okay, do not create a separate table for superclass. Create a relation for each subclass. Create a relation for each subclass. Okay, cool. I have to create a subclass. Create a relation for each subclass. So now let's see how we are doing that part. Okay, so this is it. Maybe there will be more, because sometimes when we are considering about other relations, sometimes we have to add some more foreign keys from other tables. Still, this is not the complete one. Maybe there will be more. So until we find them, this is it. Just considering this one and this one. So when you are writing, you cannot edit now. So don't close the closing parentheses. Okay, now let's go to the. We have another subclass now. So these two, is it fine? Is it fine? These are just like theories. There are theories that these steps, predefined steps to what to do. Do not create a separate table for the superclass. Create a relation for each subclass. Combine superclass and subclass attributes. Use primary key of the superclass as the primary key of the subclass. I think now it's fine, right? Okay, let's move. Next one. Please, maybe if you are not so familiar, you did not uh, study much on this part. Maybe it will be a little confusing. You have one day to catch up if you want. Please read some notes and draw the ER and map them. 40 marks. Total can change your results. Okay, let's move. Let's move to what? Let's move to instrument. Okay, about instrument. instrument does not have any relations. No, other like it has relations. I mean, like it does not have classes. So I will just write instrument. Maybe later we will need to add more attributes. I will just write instrument. Okay, now I completed two entities of musician and instrument. So I should now consider about the thing in the middle, place. So place, it's a many to many relation, many to many binary relation. So let's see what we should do. Many to many binary relation. Let's go up. Let's go up. Let's go up. Mapping binary relationships. Mapping into many binary relationships. Create a new relation. Create a new relation to represent the relationship itself. Okay. Create a new relation to represent the relationship itself. Okay, I will create one. Include foreign keys from both participating entities. Include foreign keys. Foreign keys from both foreign keys. Actually, I cannot underline in this. You should underline these primary keys when you are writing it. So I will get these primary keys as my foreign keys. And actually, that's all. They are not mentioning any other more attributes. Those are belonging to this relationship. Maybe okay. Let's say maybe there was another attribute that in which day which musician took that instrument. So in that case, we should add that uh, attribute in the musician instrument table, because we cannot add that into instrument. We cannot add that into musician. We should mention that in musician instrument, the day that musician took that instrument or played that instrument. Right. Then we have what next? Okay, now this one, this one, this one. Okay. Uh, Now let's go to this contract part. Contract is okay. I will draw contract. Not draw, just write contract. Okay, maybe there can be more attributes, maybe not. So I did musician and contract. So now I should consider about the science relationship. Let's see what should we do in when it comes to a one-to-one relation. Okay, let's go. One-to-one, mapping one-to-one by relationships. The designation of okay now this is a bit complex. We should consider about participation constraints. If total participation on both sides, total participation of both sides. No, we have a total participation on one side and total participation on one side and partial participation on next other side. So total participation on one side. Okay. So designate the entity with partial participation as parent. Okay, it's just saying that it is the parent. Add the foreign key in the child table. In the total side, add a foreign key in the child table. Include the relationship attributes in the child table. Okay, so we have to add the parent's primary key as the foreign key of the child. So what do we choose as our parent? We choose partial side as our parent, partial side as our parent, and in the total side we call it child. Inside the child's table, we have to add the parent's primary key. So now I add the primary key NIC. So this is the primary key, and this one is this one is foreign key in this contract table, and this is the primary key. Okay, now this one is done, this one is done, this one is done. So then let's go to song. A song has a song ID. Cool. Now we have to consider, now we did this one and this one. So now we have to consider about this relation. About this relation, we looked about that before, many to many relations. So what should we do? We should create a separate relation for that relationship itself. These things are very boring, I know, but please keep it awake. So what should I add? Foreign keys from both entities. So primary key of musician and song ID, right? Great. Now this one is done. This one done. This one done. 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 Okay, the album is still not done. Eh? Let's do that part as well. Okay, now I did this and I completed two more relationships. So first, let's consider about this, and then let's consider about this one. So producers relationship with musician. So one to many relations. Okay, let's see what should we do in one to many relationships. One to many relationships. Mapping one to many relationships. Okay, the entity on one side is designated as the parent. One side is considered as the parent. So who's the parent? In our case, one side is the parent. So musician is the parent. Okay, cool. Then what's next? The entity on the many side is the child. So it is album. Then add the foreign key in the child table relation for the many side. That references the primary key of the parent. Oh, this is simple. That is simple. What we have to do is just add the musician's primary key as the foreign key. Then we have this one. We completed this one. Now this one contains it's one to many. So what did you do? One side is the parent and the other side is the child. So we add album's primary key as the foreign key in the child. So now we completed all the relations that belongs to album and album itself. So we can close this. And about yes, about the instrument as well. No, we don't need to keep it this open. Okay, now this genre. Genre. What are those things? Now I cannot just write genre and add genre ID and style those things. Now I should consider about overlapping. What is this? Partial overlapping. Partial overlapping. Partial overlapping constraint. Partial overlap. Create a relation for the superclass. Okay. Create a relation for the superclass. Create a relation for all subclasses. Combine. What does that mean? Okay. First thing is simple. No, I will just make it. Then create a relation for all subclasses combined. Include the primary key of superclass. Add attributes for all subclasses. Add discriminator columns to distinguish subclass types. Okay. What this means is this. I will I will uh, I will add a new table to combine all the genres. Just choose an appropriate name. It's not. I don't know. I just add this name. So include the primary key of the superclass. Use the primary key of the superclass. So the primary key is same. Genre ID. Then add attributes for all subclasses. Attributes of all subclasses. Okay, I forgot to add that. No. Where is it? Right. So these are attributes. I should add these all attributes in one table. What is it saying next? Add discriminator columns to distinguish subclass types. Okay, so what is a discriminator column means? Is it like this? this is what the discriminator means. So we can add boolean values like true or false here, and say that uh, this song is belong to the electric and pop both. When you can put both true in this, is electric true, is pop true, but is classic, we can set false. So when is electric is true, the tempo, there will be a value in tempo, and is pop is when is pop is true, then subgenre, that value will be also some value, or also be some value, but duration will be null because it's not classic. So that's what discriminator does. Okay, so then I did this part. Okay. So this, now we have to consider about this part, one to many. One to many, in one to many, what should we do? Who's the parent? One side is the parent and this one is the child. So in the child table, we should add the parents primary key as the foreign key. So in this song we add, okay, cool, musicians. Why I still couldn't, okay, I did this one as well, no? Okay, musicians, so I have done, no? Okay, so all the relations done, but there's a problem. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The problem is not the relation type is 10, and that is, I know, no, that is not a problem. That should be like that. But one problem is there. Can anybody spot that and tell me? No, it is not necessary that from where you got the foreign keys. Like in some examples in web, I have seen like they are drawing dotted lines from here to here like that. But madam didn't really did that thing as I can remember, and I did not do that in my assignment, and I had got 92 or something like that. So I don't think it is necessary. Uh, so there's another problem. There's another big problem in this thing. Not a big problem. There's a one relation which is missing. What is that thing? The missing part is this multi-valued attribute. We cannot see put multi-valued attributes in a normal entity. So what? Let's see. What should we do in multi-valued attributes? In my not this. That's it. Okay, handling multi-valued attributes. Create a new relation to handle multi-valued attributes. The new relation includes the multi-valued attribute, the primary key of the original relation as a foreign key to link two tables. Together, these form a composite primary key for the new relation. Okay, that is not a big thing, it's simple. So this is how you get that. Please wait, I will draw the underline in this one. This is how you get it at the end, as I feel. Solo member, band member, musician, phone, instrument, musician, instrument, contract, song, musician, song, album, genre collection. Is it fine? I don't know whether you guys are sleeping now. Is it okay, guys? Yes, Vedishan, what's the problem? Is it a hand raise? Oh,
Yeah, sorry, could you explain that last part once again?
last part means brother. What part?
What you just said.
What part? Now, okay. I will go to this one and this one. So this phone number thing, this multi-valued attribute thing.
Yeah, that's the one.
Okay. In multi-valued attribute, when you have a multi-valued attribute mean for a musician, he can have multiple phone numbers. Okay, sorry. So sorry for the gender discrimination, not he. What should I use? A musician. I will say musician. Otherwise, you guys will get angry that I used he. I'm sorry. So sorry. Musician. Musician. A musician can have multiple phone numbers. So there you cannot add multiple phone numbers in one cell. So that is wrong. So you should add the phone numbers in another table. So you should create another table for that. So there you add the primary key of the original entity, and then that multi-valued attribute. So let's think about like this. So let's say my ID is something like this, and I have two phone numbers. I think it like this. These are my two phone numbers. Then I cannot have these two numbers in two values in my in a one cell. So I create another table, and I do like this, something like this. Like something like this. So there we create a row for each phone number and add our primary key as a foreign key. Actually, the combination of these two becomes a composite key. Like we use both to create the primary key. I will write Vedation.
Yeah, I got it. Thank you.
Okay, good. Now I'm sorry that I will not do this one today. I can do these parts, but these parts and until here I can do, but I am not very confident to teach this part right now. I should I think I should study more on this normalization part, which you can get 16 marks. So I will for sure I will add the video before the noon. I wish, and I will do send that video. So I will not do this part, but I will just do this SQL part. I'm sorry that I cannot do this normalization question for you, which is very important and which is pretty complex sometimes. I don't think it's complex, but I need more confident to reach that part. So I will do this part. Okay, is it okay? Is it okay? Just sorry for that part, that thing. Okay, Viman and others. So what's an SQL statement? It's just a theory part. Just tell the SQL is used to uh, query databases and blah blah blah. And this one is the important part. Uh, Briefly describe different SQL statement types. So there are four different SQL types. What are them? What are they? Data definition language. Data definition language means that this is used to create the structures like creating schemas. Schemas mean databases and creating tables and those things. I have a note for this one as well. Wait, where did I add this? Okay, in this SQL part. No? See, SQL, what it does, it is there. Object, what is SQL? So these are the components. DDL, data definition language. This part is like setting up the foundation of your database. It lets you define structures of tables, relationships, and those things. I had the detailed one. Wait. Here. SQL as a data definition language. Data definition language is responsible for creating and structuring the database. It defines database objects like tables, columns, indexes, and actually databases, creating the database itself. SQL as a data manipulation language, so DML. So it is used to manipulate data. Manipulate means update data, like inserting, updating, deleting, and retrieving as well. When we are retrieving, we are not actually modifying, but it is also considered as a data manipulation. Uh, like actually the same language, but different use cases. Data control language, DCL. Data control language means DCL is to control who can access and modify the database. It manages permissions, who can read, write, or change data. Database administrators use DCL to grant or revoke. Grant means you are giving permission to someone. Revoke means you are taking away permissions from them. So they are becoming less privileged users. So the things they can do is getting lower when you revoke, and when you are granting, their powers go high. So that's what the DCL mean. DCL mean data control language, and TCL means transaction control language. So what does it mean? TCL is used to handle transaction, ensuring database consistency. Uh, it's like it helps manage groups of SQL commands that must be executed together. So basically, what it does in simply this something goes wrong with your database, maybe a hacker attack it, then it that person changes all the data in the tables. So now it's a mess, and there's an option in TCL to roll back to a previous state. So you can roll back to the yesterday's database state. So when you roll back, uh, that change data uh, will goes back to how it was in yesterday. So that's what normally does in transaction control language. So that's what is the answer for this one. Okay, now the coding part, I think. Yes, now the coding part. Don't need to worry. If you know, you can. And actually, the sad part is if you don't know, you cannot do that. Okay. Refer to the data in the tables below to build SQL statements for the queries listed below. Queries listed below. Okay, queries listed below means they are telling the queries what to do us. Okay, please take note that we should note that what is the mean, we should note about these things. The foreign key establishes in table bonus, yes. Reference to the worker ID field in table worker. Worker ID in worker table. Okay, it is referred in bonus table as worker ref ID. Worker ref ID. So this is referring to this. Okay, fine, no problem. Okay, condition is cascade delete. Condition is cascade delete. Okay, what does that mean? Um, in case this value is being deleted in this table, so this worker is deleted in worker table. This one is deleted. So now what happened when cascade is there? Cascade delete. This bonus table, this row will also be deleted, because when the worker is not there, why have his name in bonus table? That is the reason. So it will be deleted. Cascade delete means that. So the foreign key established in table title. Title with reference to worker ID field in workers. Okay, same here. This is here and it is referring to this one here. And in case something is deleted, then that part will also be deleted in here. We don't need to store the someone's title who is not in the company, right? Okay, cool. Academic share 20, this one. So now what's the last part? BID, TID, work ID, BID, TID, and worker ID. These are primary keys which are auto incrementing. Okay, no problem. Fine. What should we do first? Write an SQL query to retrieve details of the workers whose salary lies between 100,000 and 500,000. Okay, then we have to know about select statements. Let's go to select statements. Please, if you can go through this, not tomorrow. So like, if you are confident, don't need. Fine. Types of select queries. Okay, not this one. Okay, actually the where clause. What we need is where clause. Because of this special keyword here, salary lies between 100,000 and 500,000. This is the trigger point. This is the thing that we should consider. That between word is used to range search condition. We can search for a range of values. Like we can say, actually what we can say is this, between 100,000 and 500,000. So how to do this? We'll select what is the table name? Select from worker table where. Now the where point. Where salary I will use simple letters. How to use where salary? Where salary between like this, between 100,000 and 500,000 according to our question. Right, you get 1 mark for this. Okay, anybody got questions? No problems, then we can move. Let's move. Write an SQL query to fetch first name from the worker table in uppercase where department is admin. Okay, uppercase thing, let's keep it there for a while. You know, first let's select workers from department from who are admins. What is the department? Department is equal to admin. Okay, now this will select everything from the work table who are admins. Okay, what I want is first name now. Right now, what's the condition? The condition is uppercase. They want the values in uppercase. Okay, now how can we do that? Actually, there's a function which is, I can't remember the name that what those functions are called, but there's a function as upper. Those are called scale operators. They are called scale operators. We can use them to do that. So what lower do is convert a string to lowercase. So if we do something like this, hello world, it will go to hello world. What does upper do? Convert a string to uppercase. So we can simply see, this is this simple. Okay, what's the next one? Write an SQL query to fetch details of the workers whose first name ends with H and contains 6 characters. Okay, so this one also goes to where clause, special cases in where clause. Go. Where. Pattern matching. Pattern matching. Like we are searching for a pattern. What is the pattern? Ends with H. Ends with H and contains 6 characters. Okay. How to do that then? So exactly 6 characters mean we cannot use this percentage mark. Percentage mark means matches any number of characters. No. We don't need any number of characters like thing. We need to match us exactly. Here one character don't mind matches exact number of ones. So here let's see that example here. This example. Select owner number, if name, mail name, prior from this is an example. If name like H, then here there are 3 underscores. This means start with H and 3 more letters. Exactly 3 more letters there. So in our case, how should it be? Here 1, 2, 3, 4, 5, then H. So altogether it's 6 now. Altogether it is 6. It contains 6 characters and it should end with H. So it's a simple H. I should do simple H. So here there is 1, 2, 3, 4, 5. Why 5? Because H is already there now. So it's the 6th character. So this is how you set the where clause, and others are very simple. Right? You get the point? Okay. Now what? Write SQL statement to insert first row given in worker table. Okay, insert into okay. Worker table, no? Okay, worker table. Insert into a worker table. What are the columns we have to add? Worker ID. So these are the columns that I should add details. So the values will be worker ID. It is 1. When the values are integers, normally these auto increment. So those are integers. Auto increment things are integers. So that is an integer. So I don't use single quotes. But the name is name Monica, which is a string. I should use single quotes. Then last name as well. Then let's say salary is also an integer. So it's 100,000. Then the joining date you can specify like this inside the single quotes 2021 to I think for teaching to anyone I should ask how to add wait I will ask from ChatGPT just to confirm that how to add the date, how to add the okay just add it quotes. Yeah, other method too, but it is fine. Then the department is also a string, right? At the end, please make sure that you are adding the semicolon. Okay, now done. Fourth one is done. Okay, write a SQL statement. How many are there? Okay, 11 are there. 5. Write SQL statement to create table name bonus. Table name bonus. Okay, I will make the bonus table. Create table, bonus table. Then I should define, what should I define? I should define the columns. Int b in bid, which is primary key as they say here. BID, TID, work ID fields are primary keys which have the auto implementing as well. This is how you can do it, and there should be a comma for next column. Worker ref ID, which is an int, and I do not mind that it is the foreign key. At the end only I uh, add a sentence, add a statement that this is referring to this. The type is date time. This one is right now. This is correct. BID worker ID. No, not correct. Not yet correct. Did we mention about foreign keys? No. What is the foreign key in this worker F ID? Now I should mention where does it refer. It is referring to the foreign key establishes in table bonus with reference to worker ID field in worker table. And the original primary key is worker ID. So this bonus table is referring to this worker table which is connecting with this worker ID in that table. Connecting using this, and that's what I mentioned here, right? So is it fine? Is it okay, guys? Okay, what's next? Actually, you get 7 marks for this now, so make sure you are doing it at your best. Okay, write an SQL query to retrieve all the uh, details of workers who joined in February 2021. Okay. Joined on February 2021. For that, I think in Madam's note there was a way. Actually, I can't remember, but there's a way to do this in scale operators. This one. Where? What's extracting? You can extract something from a date. You can extract year. You can extract month. Right? Maybe there's another way, but okay, I will. Maybe we can. Where's the paper? SQL query to retrieve all the details of the workers who joined in 2021 February. This part we have to consider. Okay, let's use that extract part. But if there's an alternative way which is easy, I will let you guys know. This is not okay. This one is the column name that which I am extracting the data. This one should be equal to 2021 and February. No. So this select all from worker table where extract year, date, time, joining date equals 2021 and month joining date is equal to 2. I am sure that there should be an easy way, but for now just keep in mind this is a way. Okay, so what is next? Write an SQL query to fetch worker names. Okay, print first name, last name in a single column. Okay, with salaries larger than or equal to 50,000 and smaller than or equal to 100,000. Okay, fine. Okay, now we should use another scala operator. Scala operator, what is that? What is that? It was here. I will show you what you should use. Where's that? Where's that? It is concat. You can concatenate two strings, which is what we exactly want. Concatenating two parts. What are the two parts? First name and last name. This is called an aliasing. I am saying that this part, give this as the column name of full name. So when it gives the output, it will show as full name. Full this. It shows us an table. No, shows us a table, and that tables the column name will be will look like full name. And from where salary, right? Where salary is larger than that and smaller than that. Is it okay? I guess it is okay. It is not very complex. Write an SQL query to fetch the number of workers for each department in descending order. Please wait, I will drink some more and join with you. Okay. Write an SQL query to fetch members of numbers of workers for each department in descending order. Descending order. And the number of workers for each department. So this is like counting. No? So in SQL, there's something called as aggregate functions. That's it. You can use these functions to do some calculations. You can use count to return the number of values in a column. So this is what we want. Number of workers now. So in each department. So when it comes to in each department, I will show how to do it. So we can count group by group by using this group by clause. When we use group by clause, the output will be showed as groups. So this will count for each department. This is how you do it. So uh, there we will get a table, and in the table we will see the department, and uh, in the next column it will show us the count of numbers in that each department. Okay, that is that is what is asked. Okay. If you guys have any questions, please ask. Okay, write an SQL query to fetch the list of employees with the same salary. Who? Okay, here I think we should do a join now. I have not done that test, but she told away, and I will try that one. Wait, and later I will ask. Let's ask from ChatGPT whether it will work or not. Yeah, I should get two tables because to actually the one same table, but I should get them two types because I need to compare same columns with each others now. From because I use this S1 because I use S1 and S2 like this. See, from same worker table, but I gave them two names. So this is right now, I think, and this will give some kind of wrong answer because not a wrong answer, but not the exact thing what we need. This will give us the uh, one employee's name equal to one name, that same employee's name, like that thing. So we can re, we can stop that from happening using and. Okay, this is it. Now I will ask from ChatGPT whether this is correct or wrong. Next one, Slary. Sorry. Yeah. See, sometimes I mix typos. Here. This one salary. So the code is correct, but see, this is another alternative way of doing this same thing using joins. It's also long. So I think this method is a bit easy. I'm just going because nobody's asking a question. I don't know whether are there questions. Please ask if you have any question. Okay, write down a SQL query to fetch departments which have less than 5 workers. Oh my god, I think we used the same thing. Now, what I have to just say is number of workers smaller than 5. No, number of in a where clause at that number of workers is smaller than 5. So should I write this where? Is it should it should this be like this, or is there a wrong? Is there a problem in this? And actually, there's a problem because there's a way you should write select statements. In select statement, this is the order. First select, then from, then where, then group by, then having, at last order by. So this should not be the end. This should be after from. Okay. Now this is what you need. It's not that hard. Write an SQL query to fetch departments which have less than 5 workers. So maybe you will. So this is it. This is just this. Write an SQL query to fetch details of the workers who are also managers. Workers who are also managers. Okay, so here, what should I select? Select. Write an SQL query to fetch details of workers. So details of workers who are managers. Okay. They are asking about uh, about a join. Now we have to get the details about workers, but what our guidance is this worker title manager. We have to find these workers out of these from. Okay. Select first name. I just selecting first name and last name. I can select all as well. From title, so I will just select all. It's not make complicated. Select all from title table T and worker table W because we need this table to access the columns in this. That's why I use this kind of a from. We need two tables. And in the where who are managers, right? Who are not managers, no. Who are also managers. So where worker title equal to manager. And so that's it. Let's check this done as well because in case this is wrong. Same as again it is just saying that without using this and then worker FID equals to worker ID, you can use a join. Actually, join was taught in the class. I am not very familiar with that. That's why I use this one. So wait, I will use that one. Okay, here worker table. I'm getting worker table. Then I will join. Okay, how can I join? Okay, so this is it using joining two tables. How to join? Where worker ID and worker ID in worker table and uh, title table. In the title table, worker FID is equal. That's how you can do it. So what I did is connecting worker table and title table using this worker FID and worker ID, connecting these two. So somebody put a message. Very nice. Now you guys may leave, brothers. In X, when filtering based on aggregate function like count, don't we have to use having instead of where? Oh my god, did I miss that part? I'm sorry. Which part was that? I am so sorry. We should use having part here, no? Where number of workers 5. Please wait. I will show that one. Sorry. That's my mistake. So here, like this, having, you can use count this as like this. So this one number of workers, it is fine as I know, but I will remove this. Not where using where is not correct. Use group by department. Having, Mashi, thank you for pointing that part. And in the last question, in the 10th question, and uh, we don't have to write that text. This part. This part is also unnecessary in this case. So yes, okay, that's. I think you guys got something. I will add that normalization part tomorrow. So good night, guys. And if you have any questions, please ask. It's okay. I think. Okay. Night. You're welcome. I think